All right, good morning, everyone. Welcome back from spring break. Sorry I'm not able to be here today. But we're going to go ahead and start with 10.1, which is talking about circles and circumference of a circle. Okay. So our objectives today, we're going to identify and use parts of circles, as well as solve problems involving the circumference of a circle. So a circle is the set of all points in a plane equidistant from a given point, called the center. Okay. So, guys, it's just defining what a circle is. Okay. If C is the center of the circle, okay, the circle is all points that are equidistant, same distance from C. That's why these circles have a given radius. Okay. All those points are the radius from the center. Okay. Some notation, we could call this circle C, or we could also use this circle with a center in it and C to say what that is. A segment with its endpoints at the center and on the circle is what's called a radius. So I already used the word radius, but to define it, it's just a segment with its endpoints at the center and on the circle is a radius. So a chord, next word we're going to talk about is a chord. And it is a segment with its endpoints on the circle. So a chord is just a segment with 2 points with endpoints on the circle. And the next definition then would be a segment that is a chord and includes the center of the circle is a diameter. It's called a diameter. And we'll see examples of these in just a moment here. Okay. So those are some definitions: radius, chord, diameter. It also defines circle. Okay. So as we continue here, we're going to look at examples of these words that we just defined. And I'm going to go ahead and use another tool here that we have. Let's do a radius first. So the first thing, we want to have a center of our circle. So let's do our best to put a center there. Let's say that's the center. Let's call it circle C again. So a radius, as we defined it, it was a segment with endpoints at the center and on the circle. So if we were to draw a radius here, we would have endpoints at the center and an endpoint on the circle. So out here, where that segment touches the circle, that would be the two endpoints, and this is what we call a radius. Okay. A chord, again, just had endpoints on the circle. So a chord could just have endpoints that are on the circle. So, hey, there's two endpoints on the circle. If I want to use my segment tool here again, just connect those endpoints. This segment here is a chord. It has endpoints on the circle. Our last definition was diameter, and a diameter is just a chord that includes the center. So it could have an endpoint on the circle, it goes through the center and to the other side of the circle. So that segment that I've just drawn, it's a chord that includes the center of the circle. So this is a diameter. All right, so there's examples of each of those definitions we just talked about. All right. So let's continue on here. So name the circle and identify a radius. So again, when we're naming it with the center. So this is circle P, or again, the notation we could also use circle P. Okay. So either of those is fine to name it. And then a radius, guys. A radius is just, again, a segment with endpoints at the center and on the circle. So there's a few examples of radii here. One radius would be the segment PN. PL is also a radius. again, it's got an endpoint on the circle, L is on the circle, and P is the center. One more example of a radius would be PM. Again, it's got P, the center of the circle, as an endpoint, and M, a point on the circle as an endpoint. So, PL, PN, and PM are all radii. Identify a chord and a diameter of this next circle. So, well, what is this circle? This circle, if we were to call it, naming it by the center, circle E. And then, so identify a chord. Again, a chord just has endpoints on the circle. So chord that have endpoints on the circle, JK, that'd be a chord. HG, that's a segment that has endpoints on the circle. So there's a chord. What about the diameter? A diameter of a circle, it has endpoints on the circle and includes the center. So which segment does that? Well, HG. Okay, remember, a diameter is a chord that includes the center. HG includes the center E. So that's what makes it a diameter. All right. So there we worked with identifying some of those pieces of a circle. Let's continue then. Radius and diameter relationships. If a circle has a radius R and diameter D, the following relationships are true. So the radius formula, radius is 1/2 of the diameter. Radius is 1/2 of the diameter. D over 2, or 1/2 times D, same thing. And then diameter formula, diameter is equal to 2 times the radius. Okay? So, if QV is 8 inches, what is the diameter of circle Q? So QV is 8 inches. Okay. QV is what? QV is a radius, right? So the radius here is equal to 8 inches. QV is a radius. So here the radius is 8 inches. To find the diameter is equal to 2 times the radius. So in this case, 2 times 8, which is 16. So here the diameter is 16 inches. Okay. And we can go, I mean, these formulas aren't too complex. You can go either direction with these things. Okay. So key concept here, circle pairs. 2 circles are congruent if and only if they have congruent radii. All circles are similar. Concentric circles are coplanar circles that have the same center. So concentric circles, that's an interesting one. Both of these circles here have center A, but they have different radii length. Okay. AB is the radius of this inner circle. AC would be the radius of the outer circle. Okay, so it's interesting. So circles, they can intersect in many ways. 2 points of intersection here. As you see, they can intersect at a singular point, both these ways. And they could have no points of intersection as well. As you see here, just 2 circles drawn separately, or concentric circles would also have no points of intersection. So find measures in intersecting circles. So we want to use some relationships we have to find some measurements here. So the diameter of S is 30 units. The diameter of R is 20 units. And DS is 9 units. Find CD. So we've got that DS, we were told specifically, was 9. We're told that the diameter of S is 30 units, so the diameter of S wasn't very good. Accurate. The diameter of S is 30 units. Okay. The diameter of R is 20 units, so that tells me that the radius of R is 10 units. So that would be 10, what I just drew there. What's the radius of circle S? The radius of circle S would be 1/2 of the diameter, so 15 units. So from C to S, 15. Hey, right there, that's useful. Okay. If CS, we're looking here, CS, I'll highlight. That is a radius of circle S, which is 15 units. A segment inside of there is 9 units. That means we would have 6 units left. So CD is 6. So we had to do some work, some breaking down to find out what we needed to know there. Okay. But again, the math that happened there, we knew that the radius of S, we had to find the radius of S first. We knew that was 15. So 15 minus the 9 that was SD gave us 6, which was CD. All right. So a little bit of problem solving there. Okay. We'll stop at this point, and I'm going to have you guys do some homework here. Let's go as 10.1, part 1, and we'll do page 701, 10 through 21, all of them. Okay, so that'll be a good stopping point for today.